Today, Carlos and I will be talking about sickle cell anemia. So, sickle cell anemia is a genetic disorder whereby it affects the functionality and the characteristics of the red blood cells. So, to understand sickle cell anemia, I must first quickly overview the functionality of the red blood cell and how it works. In this picture, we can compare a sickle cell erythrocyte on the left side compared to a normal healthy erythrocyte on the right side. So the red blood cells, also known as erythrocytes, are one of the components of blood alongside platelets, white blood cells, and plasma. These red blood cells are produced in the bone marrow, and as soon as they enter the bloodstream, they lose their nucleus. Once in the bloodstream, the function of these red blood cells is to pick up CO2 and deposit oxygen when they're at regular cells, and then when they enter the capillaries, they diffuse out the CO2 and take in the oxygen from the lungs. So essentially to carry out oxygen to the rest of the cells of the body. And it is the hemoglobin that allows these red blood cells to do it, which is a protein inside the red blood cell that is responsible for pushing the rate of diffusion beyond its equilibrium for these two gases. And this is exactly where the sickle cell anemia genetic disorder changes things. It changes the hemoglobin protein in the red blood cell. Normally people without sickle cell anemia will have hemoglobin A, and then people with sickle cell anemia, the genetic disorder, what they have is referred to as the hemoglobin B. For someone suffering from sickle cell anemia, when the red blood cells are still in the bone marrow and therefore still have a nucleus and therefore DNA, there's a genetic mutation found on the 11th chromosome and on the beta globin gene. So when the RNA polymerase copies this mutated information from this specific gene to create the messenger RNA, this messenger RNA delivers this mutated information to the ribosomes. These ribosomes then therefore turn this genetic information into beta polypeptides, which consists of 2 of the 4 polypeptides found in the hemoglobin protein. There's 2 beta polypeptides, and then there's 2 more alpha beta polypeptides. So here I have exemplified the difference between the erythrocytes of someone suffering from sickle cell anemia and someone who is healthy. In the case of the person suffering from sickle cell anemia, for simplicity's sake, I have shown only 3 hemoglobins, even though there are much more, obviously, within each erythrocyte. So in the hemoglobin molecules of the erythrocyte for someone who's suffering from sickle cell anemia, the beta polypeptide chains create a linkage between these hemoglobin molecules, which create these long rods or polymers of hemoglobin molecules. While in this case, for someone who's healthy, the hemoglobin molecules, the beta polypeptide chains are not linking the hemoglobins together, so they're free to move around. I compare it a lot like a bag of marbles. So this one would be like a regular bag of marbles, the bag being the erythrocyte itself, and the marbles being the hemoglobins. While in this case, if you were to imagine a bag of marbles where all the marbles were lined up, then the bag of marbles would take a longer shape, and because there's several rods or polymers in the sickle cell erythrocyte, then it creates the shape of a sickle. Now the significance of this changing shape for the sickle cell erythrocytes comes into play during the movement of these erythrocytes in the blood vessels. So if we can observe here in a healthy erythrocytes, they're able to normally move along the blood vessels, especially when the blood vessels get much thinner. So when the veins start to branch off, they don't get stuck during these forks kind of in the veins. Now here, however, in the sickle cell erythrocytes, because they have roughly the same volume, but their shape is much different, they're more elongated rather than circular, as well as the fact that they're not as malleable, makes it so that they can get stuck here when these veins or
blood vessels branch off. So, as you can imagine, this will lead to complications that I will further discuss soon. Due to reduced oxygen distribution throughout the body's tissues, there is a long list of common symptoms associated with this genetic disorder. This list includes fatigue, pain, dactylosis, bacterial infection, splenic sequestration, lung and heart injuries, leg ulcers, aseptic necrosis, and eye damage. The sickling of erythrocytes is constantly present in victims of sickle cell anemia. However, the sickling can be aggravated or promoted by the conditions of low oxygen levels, increased acidity, dehydration by decreasing the volume of blood. These conditions can occur if an injury is experienced to the body's tissues, if you're dehydrated, or if you're under anesthesia.